So last section we talked about what? What do we learn? What do we?
Estimating.
We the ho and the ha, right? We talked about how to set the actual ho and the ha, right? So we had to set the null hypothesis and the alternative hypothesis, and then we were going to do what? What was our grand scheme of what's the process are we doing? We want to reject this guy, right? We want to. And what is our justification? How do we justify rejecting this?
If it's less than p, or
If
5,
the p-value, right? If the p-value and alpha, which one has to be greater?
p-value, no, alpha.
If the alpha is greater than the p-value, then we get to reject the whole, right? If the p-value is larger than the alpha, then we do
Fail to reject.
right.
Do not
Never
accept.
never accept the whole.
Never.
Always reject or fail to reject. Okay? Okay, we're good there. Okay, so that's basically what it is. So what we need to learn as of yet, so we know this, right? This is going to be given to us at a significance level of what, right? Or it's a 95%, 99%, 90%, or whatever it may be, right? So you're going to be given this, so there's nothing to calculate here, but we need to be able to calculate this. Okay, this is the thing that we don't know how to calculate yet. Okay, and the way you do that is on the preview of that is on table 8.2 on page 362. We kind of looked at this the other day. Okay, so that is what is going to tell us how to actually calculate the p-value. We are not going to learn today how to calculate that p-value. That's going to be in 8.2, 8.3, and 8.4. Okay, 8.2 will be your proportion, 8.3 will be your mean, and then 8.4 will be your standard deviation. Okay, you will learn how to calculate p-values. Okay, but again, in the grand scheme of things, the reason why you need that is to compare it to this, and then we can make a decision whether we're going to reject or fail to reject. And at the very end, what do we need to do? What did I tell you we needed to do?
Conclude.
You have to conclude within the context of the question, right? Right. So if you go to let's go to page 363, or actually, no, let's go to page 362. There's a definition there of the test statistic. Daniel, read that for us.
The test statistic is a value used in making a decision about the null hypothesis. It is found by converting the sample statistic to a score with the assumption that the null hypothesis is true.
Okay, all right, good. So basically, it is the test statistic is something we use when we're calculating this. Okay, that's what the test statistic is. All right, moving on, then we have a critical region on top of page 363. Critical region or rejection region is the area corresponding to all values of the test statistic that cause us to reject the null hypothesis. So it's called the rejection region because these are the regions which allows us to reject the whole, okay? Which is what we want to do, all right? So that, if you look on page 363 on the right-hand side, you see there is a sign used in H1 for the null hypothesis or sign used in whatever and whatnot, okay? It tells you what those things are, okay? So there's a left-handed tail, right-handed tail, and then there is the two-sided tail, okay? Similar as what we've done before, right? Remember we had two-sided tails and we had sometimes had on the right-hand side, sometimes on the left-hand side. Same thing, okay? Then we have the p-value method, definition. Spencer, read that for us.
In the hypothesis test, the p-value is the probability of getting a value of the test statistic that is at least as extreme as the test statistic obtained from the sample data, assuming that the null hypothesis is true.
Okay, so assuming that the null hypothesis, so we're always assuming that this is true because that's our first, that's what we said, right? Because this is the guy we want to tear down, right? But we're going to, the logic is if this was true, the p-value would be this. And if that p-value is so extreme or so statistically significant, we get to say there's no way that this can happen by chance, or since we assume this is true, we can basically say that it's not true, right? Because the p-value was so small, right? Flip the page, and then we have this nice looking flow chart, which I will let you guys read later on. You can do that as you're doing the homework. And then, but it's basically stuff that we've already talked before. P-value, testing controversy, let's skip that right now, so no, we don't need to worry too much about that. The critical value method, so this is on page 365. In a hypothesis test, the critical values separates the critical region where we reject a null hypothesis. Okay, blah, 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 blah. And this is the critical value. Again, we will do the same thing, okay? It's the same way of doing things, but actually, you guys do need to be able to find the critical value, but most of my questions on the test will be, can you actually perform or find, can you actually find the p-value, okay? And you'll be learning doing the p-value with this, okay? It'll be on your calculator, all right? Okay, so in step 7, we say we make a decision either to reject or fail to reject. We talked about that and flip the page. Step 8 is basically the restating the conclusion or concluding within the context, right? It says, restate the decision using simple and non-technical terms, okay? All right. Again, if you just say, p-value is 0.01, it was less than the alpha, we reject the whole. That's not enough, okay? You have to tell me what that actually means. So that's that, accept or fail to reject, multiple negatives, blah, 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 blah. And then, blah, blah, blah. Okay, we're good there. We are done for the day. Tomorrow we will do type 1 and type 2 errors. Okay. I would like